Hello everybody, welcome back to Computer Science 4300. Today we're going to be talking about assignment 4, so this is exciting. It's the last assignment of the course, but of course you still have a big project to work on. So today we'll be talking about all the different things you're going to be doing in assignment 4 that we learned about in the last 4 information lectures, I guess we'll say. Also realize if you're watching this live that assignment 3 is due tonight, so please get that submitted on time. So, that being said, let's hop right into assignment 4 and try and get this lecture done in time. So here I have the solution to assignment 4, and what I'll do at first is I'll just, as always with all the assignments, I'll run the solution to sort of give you an informal description of what you're doing. And then I will go through the README file and show you exactly what you have to do. And then we'll go through the code to give you some code samples and stuff for the assignment. So here I have the solution for assignment 4. So let's go through that. Or let's show you the solution. All right, let me full screen this a little bit. There you go. So you can see this a little better. So this time we have a Zelda game instead of Mega Mario, so definitely not Zelda. And as you can see, I actually have some sounds here, so I'm going to turn on my desktop audio, and hopefully you can hear these sounds. Let me turn it up just a little bit more. All right, can you hear those sounds? If you're out there live, please let me know. I think you can. So here we have a top-down Zelda-like game. It is not exactly like the original Legend of Zelda for the NES, but it's close enough for our purposes. So here we are controlling, it's like a top-down view. We are controlling Link. We can attack with a sword. We've got some NPCs walking around, so we're going to talk a little bit about very basic AI functionality. We're not talking about deep neural nets in this class for sure. You can see over the head of my character, I've got a health bar. And in this game, you have, you and the NPCs have health points. And so Link has 3 health points here. I think this guy down here has 7 or 8. I can't count properly. And your weapon will deal a specific amount of damage, and enemies will deal a specific amount of damage. So if I come down here and I start attacking this NPC, it's going to take that amount of hits to kill the thing, okay? Now, like Zelda, there are different screens. So if I walk to the left, now I'm in a different screen, right? Or this is like a grid view. If I walk down here, I'm in a different screen. And oh, look at this. This guy is chasing after me. So what's happening here? Well, I'll kill him first and then I'll explain. So I can reset the game by hitting the Z key in my solution. But I can toggle on this debug view. So this debug view, you've had this in assignments before, but what we have now in this assignment, which we will go into explicit detail about, is this ability to, we have vision in our game, right? So here we see some lines, and any NPC that has the follow behavior, which we'll get into, if they can see me, if they have a direct line of sight, they will chase me. Also, tiles in this assignment can also have different properties. So tiles can either block movement, block vision, block both, or block nothing, okay? So if you see a black outline here, that means that our tiles block movement and they block vision. So vision goes from the center of one NPC to the center of the player. And if that line is not blocked by any vision blocking thing, then this NPC will come toward me. So you can see this line here is blocked by these lines. And so as soon as I go up high enough that that is no longer blocked, this NPC will start to chase me. Okay, so that is what, that's what happens in this game. So let me kill this NPC. And now we'll go over here and I'll show you something else. So these blocks that are outlined in blue, they block movement, but they do not block vision. So you can see here that this NPC can actually see me, but they're blocked. The movement of this NPC is blocked by the water, right? Oh my god, I've got stuff coming to chase me from across the world. So let's go back in here, and then I'm gonna go up to this spot, and now I can see as well that these tiles here block movement and vision, but if I come over, then this NPC will actually come after me. So let me reset real quick. I want to show you something. So if I damage something in the game, including myself, then if anything walks over a heart piece, it will be healed. So you or the NPC. So if I go take damage, then I can come up here and I can grab the heart. NPCs can also have a certain amount of damage, so that one did 1 damage to me. This one deals 2 damage to me. Alright, let's see. Let's kill that one, and now we'll go over here. So in this part of the map, all of these NPCs block vision, but they don't block movement, right? So these here are on patrol. So patrol is another behavior. Patrols just go back and forth between 2 patrol points, and I've got some debug code here to print out those patrol points. So here, this NPC, it's actually a pretty interesting thing where he'll come towards me until one of these NPCs block the vision. So that's kind of cool. So let me just kill these. And now you'll see that this guy will be less hindered in coming towards me. So he'll walk towards me until the vision is blocked, and then keep walking towards me. The very last thing is another cool thing that you can do. Oh, this NPC has 4 patrol points, and down here you see that I've got a little tree structure in here, but I can't walk into it. However, if I turn on debug mode, you can see that this tile down here is colored red, meaning that it blocks vision, but it doesn't block movement. So if I come down here, I can make little secret areas like that I can walk through by making this not block movement. And I think the last feature of this assignment is that there are some tiles on the map that are pure black, like this one, and if you walk into a pure black tile, it will teleport you to a random black tile. Okay, so that's pretty much it. Oh, the last thing we have to do is the camera. So right now I have a camera mode where I am in each room, and each room, the camera is fixed to that room and does not follow Link around. But if I hit the Y key, now I change the camera to be a follow camera. Okay, so you can see here that this drastically changes the gameplay, and I can see that the camera is completely different. So now that I've sort of shown you, and that's it, the level that I've made is just these 5 areas. So this is one area to the left, to the right, up, and down. So let's have a look at the README file, and we'll go through this together and in excruciating detail figure out what you have to do for the assignment. So I've got the same spiel at the top here that I'm not going to read. It's basically the same thing as assignment 3. So the program specification. In this assignment, you'll be writing the game that was just presented, and it must have the following features. So assets. Just like assignment 3, entities in the game will be rendered using various textures and animations, which will be loaded, and we're calling those assets, along with fonts and sounds. So now we have sounds in our game as well. Assets are loaded once at the beginning of the program and stored in the assets class, which is stored by the game engine class. And all assets are defined in assets.txt, and it has the syntax defined below. We won't necessarily go over that syntax again because it's the same as assignment 3. So, for legal purposes, the player entity in the game is not Link, which has several different animations. So run down, run up, run right, stand down, stand up, stand right, attack down, up, attack down, and attack right. You must determine which direction and state the player is currently in and assign the correct animation. The player is assigned the following animations in the direction facing. Please note that left will be accomplished by mirroring right. So you can accomplish left by just mirroring right like we did in assignment 3. So stand in the direction. So stand dir just means stand up, stand down, stand left, or stand right. That's the direction. So stand direction is when no input or both opposite inputs are being given to the player. Run direction is when move input is given to the player in some direction. And attack dir is when the player's sword is currently visible from an attack. The player will move with the following controls. Left is A, so it's W, A, S, and D, standard controls, and the space key. And the player can move up, down, left, and right at any time during the game. And the player can only move horizontally or vertically at any given time, so it cannot go diagonal. And if opposite directions are held, the player will given a stand animation. So what does all of that mean? Well, we'll go look at it. So in more detail, if I am moving to the left or moving to the right, I am playing that little walk animation, right? So by default, there is only a stand right. So when Link is not moving, he's playing the stand animation. So stand right is the same thing as stand left. It's just flipped in the X direction. If I stand down, then Link is facing sort of the camera with the shield. But standing up is not the mirror image of standing down because you're going to see the back of Link. So there is a different animation for up and down, but left is just the flip of right. And so here we have moving right, moving left, moving up, moving down, and standing versions of those. And we also have attacking versions of those. So you can see here that Link kind of spreads his legs a little bit as he swings the sword. All right, so those are the different animations. And of course, there are some animations here for the NPCs, but they don't change based on their state. Now, if I hold left and then I start pressing up, my Link does not move diagonally, right? You can see there that I have to move in a sort of step pattern in order to move diagonally. So you have to detect that, and you cannot move diagonally. And if I'm holding both keys at the same time, then Link is just standing. He's not doing anything. All right, so that's the movement in the game. The player can only attack once its current attack animation has finished. So what that means is that if you see here, when I attack, there's like a delay. There's like, I don't know, a third of a second or a half of a second or something like that the sword is on the screen, and I cannot attack again while that animation is currently playing. So that's something that you're going to have to deal with. The player collides with tile entities in the level whose bounding box blocks movements and cannot move through them. So as I said before, everything in the game now has two Boolean flags, whether it blocks movement, whether it blocks vision, and it can have either of those be 0 or either of those be 1. Okay, so it can block nothing, it can block both, or it can block one or the other. And if something blocks movement, then you have to do collision with that. And the cool thing is that all the collision in this game, you can use the exact same collision code from Assignment 3, and it will just work, okay? Except nothing special happens when you hit something from above or below in this game, unlike in a platformer. So the collisions are actually a little bit easier in this game. The player will be given a bounding box of a size specified in the level file, so that's just like Assignment 3. The player will be given a C health component, so we have a health component now that specifies how much health something has, and it has a maximum health that is specified in the level file. So we'll see that once we get to the level file. When the current player's health is less than or equal to 0, the player respawns, and the Link die sound should play. And if the player has an invincibility component, so now we're getting some status effects as well. If it has an invincibility component, it takes no damage from enemies, and its sprite is made transparent. The duration of the component is reduced each frame, and when the duration reaches 0, the component is removed, making it vulnerable to attacks again. And so what this means is if you've ever heard of invincibility frames, or iframes in a video game, that's what we're doing here. So what happens, let me read this one and then I'll go back into the game and explain all of this. When the player collides with an enemy, and Link is not invincible, the player's current health is reduced by the enemy's damage component, the Link hit sound should play, and the player is given a C invincibility component which lasts for 30 frames. So, let's go back to the game and I'll explain what all that is about. So, the way that you're going to take damage in the game is, let me turn on the debug here, is if your bounding box collides with the bounding box of an enemy, Link is going to take damage. So just watch. I'm going to take damage, right? But if you don't have some way of saying, okay, I just got hit, don't take damage again for a little while, then every single frame that you are colliding with the enemy, you're going to be taking damage. And so you'll die almost instantaneously, right? No matter how much damage the enemy does, because it'll be hitting you 60 times per second. So what we do is we have something called invincibility frames, which is for a specific amount of time, maybe that's, I don't know, half a second or something, or maybe 1 second. After I hit an enemy, you can see that Link becomes a little bit transparent. That just visualizes the iframes, and you get an invincibility component. And while that invincibility component is active, I am not taking damage from enemies anymore, okay? So you can see that there's a period of time where I'm not actually taking damage. When I do finally die, then Link respawns and you get that sound that plays. And after a specific amount of time, you should lose that status effect of invincibility and you'll be able to take damage again. So that's what all of that means. Alrighty. Next, other entities. Each tile and NPC in the game specifies 2 booleans values of whether it blocks movement and whether it blocks vision. If a tile blocks movement, the player collides with it and cannot pass through it. If an entity blocks vision, then it does not affect enemy line of sight. Then it does not affect enemy line of sight. Okay, that doesn't make sense. If an entity blocks vision, then it affects enemy line of sight, right? That should be what it says. All right. So if an entity blocks vision, then it affects enemy line of sight. It can't see through it, essentially. So it's a good thing that I'm reading through this here. The bounding box has 2 new booleans. C bounding box, your bounding box component, where before it only stored the size, now it will have 2 new boolean values to reflect those changes. When the player steps onto a tile with the black animation, meaning it's just a black tile, they are teleported to a random black tile on the map. And I already showed what that does. So attacking. Oops. When the player attacks, a sword appears for 10 frames and then disappears, so it's 1/6 of a second. Approximately 1 tile away from the player in the direction that the player is facing. The player's sword should be given a bounding box equal to its animation size. When the sword collides with an enemy, it deals its damage component worth of damage to the health of the enemy that it collides with. The sword should only do that damage for 1 frame, and then its damage component should be removed so that it does not deal damage for each frame that it overlaps. So this is kind of the same thing as what was happening to Link, where the sword shouldn't do damage every single frame that it's active. So think about this. If I attack this entity, and the sword is active for 10 frames, then if all you do is say, okay, if this sword collides with an enemy, deal 1 damage, then I will actually deal 10 damage because its bounding box is active for 10 frames, right? So what we do in this game in order to accomplish this is everything deals a specific amount of damage, right? NPCs deal a specific amount of damage, and the sword deals a specific amount of damage. So everything that deals damage has a damage component, and we can accomplish the sword only dealing damage for 1 frame by saying, okay, if I've collided with an enemy, remove the damage component from the sword. And that's how you accomplish that. That's what that means. When the sword is swung, the slash sound should play. When the sword collides with an enemy, the enemy hit sound should play. When an enemy's health is reduced to 0, it should be destroyed. And when an enemy is destroyed, the enemy die sound should play. So that's all of the different attacking stuff in the game. NPC Entities. NPC Entities will be given an AI behavior in the level file, either follow or patrol. So that'll be specified in the level file along with the NPC and its its properties like animation and its position. So the follow behavior means that it will follow the player when the player is in direct line of sight of the NPC, or head back to its original position when not in line of sight. When an entity is at its home position, it should not oscillate, meaning that when it gets back, you're going to say, like, you're not going to say, okay, is it exactly on this pixel? you're going to say something like, is it within 5 pixels of its home location or something like that. Otherwise, you could be moving around it and oscillating, and you'll see what I mean when you get to it. It'll definitely happen to you. Patrolling behavior means that it will move toward a series of patrol points, looping back around to the start when the final one is reached. An NPC has reached its patrol position if it is within a distance of 5 from it. Okay, so that is what we're doing. So if we look back at the assignment, this NPC right here has a follow behavior. So once it's out of line of sight, it will come attack me. All right, this one down here has a patrol behavior, and it has 4 patrol points. And you can see that it goes 1, 2, 3, 4 along its patrol points. Okay, so that one, all this stuff is specified in the level file, and you will read it in. And if an entity has a specific behavior, then you're going to add those components to the NPC. Tiles. Tiles are entities that define the level geometry and interact with the players. Tiles can be given an animation that is defined in the assets file. They will be given a bounding box equal to the size of the animation. And the current animation, this is all the same thing from assignment 3, can be displayed by this command. You already know that from assignment 3. The only other thing is that if a tile is given the heart animation, any NPC that collides with it should have its health filled to the maximum, and then the tile is destroyed. Okay, so that's like picking up an item. Drawing. The game window is given a fixed size of 1280 by 768 pixels, and the reason for that is because with 64 by 64 pixels, this is an even amount of tiles. So we have 20 tiles wide and 12 tiles high. Rendering of all entities is done for you, so I've already done that, as well as the debug rendering with the F key and the R key toggling textures. So I forgot to show that before, but we can do the same thing as assignment 3 where we just turn on this, and then you can see all the different types of tiles. And here, if it's white, it blocks neither vision or movement. If it's black, it blocks vision and movement. If it's blue, it blocks movement but not vision. And if it's red, it blocks vision but not movement. All right, you are required to change the camera position of the game to alternate between 2 modes based on the mFollow variable. So there's a variable called follow, and if this is true, so if follow is true, then the camera is always centered on not link. And if it's false, then it's in room mode, okay? So it's centered on the middle of each room. Now, one of the more annoying things about this assignment is this camera stuff, okay? So rooms of the level, so what I'm calling rooms in this level, like, let me just go back here. Let me read this first, then I'll go back and show you. So each level is split up into individual rooms given an XY coordinate. Rooms, XY, room XY is defined by the rectangle X times width, Y times height, width, height, where width and height are the window and height, or the width and height respectively of the window. When NotLink moves to a new room, the camera should center on that room. So you kind of know what I'm talking about already, but I'm going to explain this in detail now. So here I am centered on a room. This is room 0, 0, okay? So if I move to the left, I am moving 1 room to the left. So now I am at room -1, 0. Inside each room, you have tiles, okay? So here, you know what? Let me get to the level specification before I explain this in detail, because I'm going to bring up the blackboard, but I want the level specification to be done first. But no, let me bring up the blackboard, and I'll show you what I mean by rooms. So here's the blackboard. So the game is going to be specified by rooms. So here we go. Here is 1 room. Let's say this is the starting room right here. Okay. So that's the starting room. This is, what was that one? Okay, so this is, I gotta move the font size down a little bit. Okay, so this is room, I'll say R00. All right, so that's the room that we start in. this room goes from pixel 0, 0. So this is pixel, right? Or world coordinates. Pixel 0, 0. All the way to pixel width height, where width and height are the width and the height of the window. Okay, so that is this room. So as I said in the in this over here, room XY is defined by the rectangle x times w, y times height, width, height. So that's what I'm doing now. So if we go 1 to the left, then I'm going to be making this room. So that's this room. I'm going to draw that in white. So this is room -1, because it's to the left, 0. So this one here, this is P, and this is, well, what was the formula? Negative width, 0. And then down here, we have 0 height. See that? So this is negative width because it's -1 times width. This is 0 because it's 0 times height. Down here, this is the bottom right of that. And I'll just do one more example. So if we go down, then we have this room. Now, this is going to be room 0 in the X direction and 1 in the Y direction. So the top left corner of this is going to be 0 in the X and height in the Y, right? So 1 times height. And down here, this is going to be width in the X direction and 2 times height in the Y direction. So what you are doing when you have the when you have the room view enabled is you are constantly every frame, and we're going to show what the, we have a camera system in this game scene. And so you're going to be constantly monitoring the position of not link. And whichever room not link is in, so for example, here, if link is right here, then you're going to have to calculate which room is link in, and then center the camera based on which room that they're in, okay? But, so let's say that this is, let's say that this is my current camera view, right? So I've got this, no, some people can't see red on blue very well. Let's go with purple. So let's say that this is my current camera view up here. So if I'm on room view and link is in this room, my camera is going to be centered on that room. If link goes to this room, my camera is centered on this room. But if the follow camera is on, then the camera is going to be following around link inside the level. All right, so you have to figure out which room link is inside, and then position the camera based on that one if it's the non-follow camera. So you should all be capable of doing that pretty easily. All right, so miscellaneous. Here, the P key pauses the game, the F key toggles the wireframe, R key toggles the textures, Y key is going to toggle between follow camera or room camera, and the escape key should go back to the main menu or quit if you're on the main menu. There's going to be a couple of different configuration files in this, and we know what the assets file is already. It has not changed since assignment... Excuse me. It has not changed since assignment 3. However, it does have sounds in it, so I don't know why I didn't include that. So sound asset specification, this is the exact same thing, and this is the sound name and the sound file path. So let's quickly go look at the assets file so you can see that it's the same. Here we have a bunch of textures. There are a lot more textures in this assignment. Here we have a bunch of animations based on those textures. We have some sounds, and we have some fonts. Okay, so the SFML supports Wave and OGG. Someone had a question, but it's not relevant to the course. So I'm only answering questions that are relevant to the course, so I just had to read that real quick. Okay, but the thing that is important is the level specification file. So in the level specification file, we've got player specification, we've got tile specification, we've got NPC specification. Okay, so we'll go over the player specification first. So let's open up a level file, and we'll go down to where the player is. So this is an example of the player specification. So the player is XY, BX, BY, S, and H. So that is the spawn position of the player in X and Y coordinates. This is the bounding box size of the player. So this is the bounding box X and the bounding box Y. We've got the speed of the player. And so speed of player movement is really easy in this assignment. Since you can't move diagonally, then the speed is just how much you move whenever you hold the button. And you've got the maximum health. So here, if I increase the player's maximum health to 13, and then I rerun the game, then, oh, do what I say, not what I do. I don't know why, but the solution doesn't do that. Okay, so apologies. I guess the solution has a mistake in it, but you're getting marked based on the spec, not based on what the solution does. So the player's maximum health should be read in from here. Next, we have a tile specification. And the tile specification, if I go to a tile specification, so for example, this one down here, it has the animation name first. So here, this is rock BM. That's just, you can go look at what the tiles are. The room coordinate and the tile position within a room. Okay, so the room coordinate RX, RY, and then the tile position TY. So let's have a look at one of these black ones. Okay, so we have tile black 0043. Let's have a look here. Okay, so I'm going to take a screenshot of this. And now I'm going to come over here to the blackboard, and I'm going to paste that screenshot in the blackboard. So in assignment 3, we had a grid, and because we had a 2D platformer, we started that grid in the bottom left. This time, we are starting the grid in the top left, because it is not a platformer. So let me undo this. I'll make this a little bit bigger. Here we go. So our grid is going to look just like it did in the last assignment, where we have horizontal lines. So there are 12 grid lines in the Y direction and 20 grid lines in the X direction. So I'm trying to draw these as best I can. Okay, I've gone a little too much here. Oh, let me redo that. I've drawn my X ones too big, but trust me, these are squares. 1, 2, 3, 4. Oh my God, I'm butchering this thing. Okay, so this is really butchered. This is supposed to be, this black tile is supposed to be, if we see here, at X position 4, Y position 3. So essentially, if we, all right, let's just copy and paste this. So now I've got something that's sized correctly. 0, 1, 2, 3, 4 in the X. Oh, geez, you're not looking at this. Okay. Why isn't... Oh, the thing... Have you not been seeing any of that? I hope you have been seeing it. So I'm not sure what you were just able to see because I looked over. So here's the tile. Apologies for that. I forgot that the assignment was full screen. Here is how the tile system works. We're in a specific room, so the room has a coordinate. By default, this is room 00 that we start in. And if we look over here, the black tile is supposed to be in room 00 with position 4-3. That is the tile position. You saw me butcher the purple lines? Perfect. Okay. So now I've got something that looks approximately the same size as a tile. So if I go position 0, 1, 2, 3, 4 in the X direction, and position 0, 1, 2, 3 in the Y direction. So this one over here, which is like the bottom left block tile or whatever this is called, that should be Y position 0 and maybe like X position 10 or something like that. So let me have a look over here, and Y position 0. Yeah. So tile rock bottom left is at 0, 0, 13, 0. And that is this tile right here. Okay. So that's how the coordinate system works. You're familiar with that from assignment 3. However, just realize that now tile 0, 0 is in the top left, not in the bottom left. Okay. All right. So let's erase the changes that we made to that. And now we'll keep going. So the tile specification, that's the tile. And then we have two more integers here. One is whether or not it blocks what's first. Blocks movement. And then the next one is whether or not it blocks vision. So if these are zeros, then it doesn't block those things. If it's ones, then it does block those things. Next, we have the most complicated thing, which is the NPC specification. So I'll scroll down here to one of the NPC specifications. All right, so here I have a few NPC specifications. So let's have a look at one of these. Let me bring that up on the screen. Okay. So NPCs are name, just like tiles, they are room X, room Y, tile X, tile Y. That's so it's name, room X, room Y, tile X, tile Y. Just the same as the tiles, it blocks movement or blocks vision. Next, we've got health, and that is the maximum and starting health of the NPC, and that has to be greater than 0. Next is the damage that it deals when it hits you, so that has to be greater than 0. Or I guess it could not be greater than 0 if you don't want it to actually deal damage. Then there is an AI behavior name. Okay, so down here you can see that this is patrol. So this tektite, the tektite that follows you, the tektite that patrols has it has 8 health and it deals 1 damage. It has a patrol behavior, and the patrol behavior is specified as follows. All right, so this is the patrolling behavior. And so down here you can see it says 223979. Well, what the hell does that mean? Well, the first 2, that is this S. So that is the speed of patrolling. So that is how fast the NPC moves when it's patrolling. The next number is N. That is the number of positions in its patrol. So it's going to move between 2 positions. It's going to oscillate between them. And then the next coordinates, or the next numbers, are X1, Y1, X2, Y2, X3, Y3. So that is the X and Y grid position in that room of the patrol positions. Okay? So down here, this is what this means. So this means I'm going to patrol. I'm going to move at speed 2 when I patrol. I have 2 patrol positions. The first patrol position is tile coordinate 3 in the X direction, 9 in the Y direction. And the second tile coordinate is 7 in the X direction and 9 in the Y direction. So if I go look at my assignment again, then this is specifying this one down here. And if we look, this is 3, 9 right here, and this is 7, 9 right here. And this NPC has 8 health, and it deals 1 damage when it attacks the player, or when it collides with the player. So that is the patrol behavior. And the other behavior is the follow behavior. And so if we look at something that has a follow behavior, this one is much, much simpler. It just says, okay, if I say follow, then the next thing is just the follow speed, and it has to walk toward the player. All right? So NPCs, they have the same room X, room Y, tile X, tile Y, whether it blocks movement, whether it blocks vision, how many hit points they have, how much damage they deal, then either patrol or follow. And if it's follow, then it's just one more integer where you have the speed that you follow at. Okay, so you have to read these in from the file. And the reason I include how many patrol points here is so that you can say, okay, I have patrol, right? I've detected that the AI behavior is patrol. So I know that there will be, the next thing is the speed, and then the next thing is the number of things coming up. right? So if there are 4 patrol positions, I know that I have to read in 8 values, and it's going to be X, Y, X, Y, X, Y, X, Y. So I've made it really easy for you with the file reading by including how many patrol positions that there are. And so, for example, okay, I've just showed this example here, but let's go over this one. If I have this as my specification, so spawn an NPC with animation name Tektite in room 00 with tile position 1510. The NPC does not block movement. It does not block vision. What is 2? Oh, it has 2 health. It deals 1 damage. Sorry, this is supposed to be 2. It has a patrol behavior. It has a speed of 2 as it moves. It has 4 positions in the patrol behavior, and this is the patrol behavior. Okay, these are the patrol positions. Okay, so some assignment hints. You can use all of your collision code from assignment 3 in this assignment. That is absolutely fine. And I recommend doing the assignment in the following order. So, again, like in assignment 3, there are many, many things to do in this assignment. So I recommend going through this list. This list is 14 things long. Holy crap. Okay, so there's 14 things to do in the assignment approximately. And so I recommend going through in this order, and every single time that you implement a new feature, you test to see if it works before you do anything else. Okay, so if we go over to the assignment, I believe that everything you have to do is the physics code here. Okay, so yeah, let's just go, we'll step through what you have to do in the assignment. So the first thing that you should do is implement the WASD movement for the player, okay? So that it moves up, down, left, and right when those keys are pressed. This will allow you to test rectangular collisions as soon as possible without worrying about implementing gravity just yet. So, if I run the assignment that I give you, not the solution code, but just what you are given, then this is what pops up. It's playing music, so there's music in the game. I had it disabled previously, and what I'm going to do now is I'm going to mute my speakers because that is super loud. All right, so I've muted that sound. Actually, let me just mute my sound down here. There we go. So I've muted the sound, there is music, and this is what you're given for your assignment, okay? And here, you can see Link down here. He's got some hit points, but that's it. That's like the default that I've given you. So what you're going to want to do at first is you're going to want to go to the scene Zelda. You are going to scroll down. You are going to register the actions, right? So you're going to register maybe register action W, and this is going to be up, right? You did this in assignment 3, and then you're going to come down here to the S do action, and you're going to put in if the action name is up, move up, down, left, right, etc. So do that first. So the very first thing that you should get working is Link just moving up, down, and left and right in the level. In my opinion, that is the first thing you should do. The next thing you should do, well, let's see. Gravity is not in this assignment, so I just had to read that for a second. There is no gravity, don't worry about it. Second thing, implement load level, which allow you to load the level for the level given so that you can test the rest of the assignment, right? So here, in the load level function, here is where you do the same thing that you did with assignment 3. And please, by all means, use your grid to mid-pixel function if you want to for this assignment. I don't mind if you do that. And so use the, oh, sorry, I have a get position function now, not the grid to mid-pixel. This is the new thing. So you're going to have to get position. So For every entity, you are reading in a room X, a room Y, a tile X, and a tile Y. And every single entity in this game is going to be rectangular. It's going to be square, and all the tiles are going to have 64 by 64 size. So here, you are making this function. It takes in the room XY coordinate. So this is the room XY. Remember, go back and look at the blackboard when I talked about that. And the tile XY, and returns the vec2 game world position of the center of that entity. Okay, so that's where you return it there. So in here, just like assignment 3, you're going to be loading in the level file, and you're going to be actually putting in the things in the level. And you're also going to read the properties of the player. I don't have the level file open, but you'll also spawn the player there. Just like in previous assignments, I have a player config struct where you can read in the X, Y, the speed and the health, etc. This is the collision X, the collision Y, the speed, and the health. All right, so that is the second thing you should do, is load in the level. The third thing you should do is implement spawn player so that it correctly uses the configuration specified by the level, so you can start testing collisions, because all of the collisions are specified. Next, you have to implement the camera changes that I described. So you are going to be centered. Well, if I look here, Link is currently centered at 640 by 480. So Link is going to actually have a position specified by the level file, which I think is the same position. So you have to modify this spawn player function to read in those properties rather than just have these hard-coded things. What was the next thing I said to do? Sorry, I got mixed up there a bit. Oh yeah, the camera system. So next is the camera system. So this is S-camera. So inside the Zelda header file, we have this follow variable. If follow is true, then you're going to be using the follow camera. If follow is not true, then you are not using the follow camera. So here we have the camera system. You have to do this camera logic. So I just have a little bit of sample code here. Here's the current view that we're going to be modifying. And if it's follow camera, modify the view to have Link centered in the level. Otherwise, it's not centered on Link, or it's not centered in the level, but centered in the camera. Otherwise, if it's not following Link, that you have to calculate the room-based view. And then once you've modified view, then you have to say game window.setView view. So all you have to do here is just calculate the follow camera position and calculate the room camera position. All right, so that is the camera. Then I would recommend implementing spawn sword. Oh, at any time here, you can have your actual collision. Oh, okay, never mind. I've got that next. So implement spawn sword so that it spawns a sword in the correct position with the correct lifespan. So up here we've got where's spawn sword? It's somewhere. Let me just look for it. Okay, so here's spawn sword. So you're going to implement the spawning of the sword, which should be given the appropriate lifespan. And so I think that's 10 frames as specified by the configuration or by the specification file. It should spawn at the appropriate location based on the player's facing direction. It should be given a damage value of 1, and it should play the slash sound. So what do I mean by this? Well, if I go back here, if Link is facing to the left, then it is going to spawn to the left. See that? If it's facing up, it spawns above. If it's facing right, it spawns to the right. If it's facing down, it spawns down. And I actually have it so that it's always positioned to the left, up, down, or right of Link. So I can actually, in one attack both left and right. See that? Okay, so you can do that if you want to as well. But that's where it spawns, and if Link is running, the sword position should keep up with Link. He's holding it, right? You don't just spawn it and then it sort of lags behind where he is. So that's the spawning of the sword. Alrighty. Next, we have implement player attacking and sword collisions with NPCs' health and damage. So what you do there is you go over to the physics function and you can do your overlap stuff. So you've got all that code from assignment 3. You're just going to copy and paste it into here so it's working properly. And then you go to your collision system, scollision, and you are going to implement all of these different types of collisions. So entity tile collisions, player enemy collisions, sword NPC collisions. Those are the ones that you should implement first. Then implement player animations to correctly animate, based on the state. So then do your animations. So there is an animation system, I think, is there? Yep. So implement player facing direction animation, implement the sword animation, and implement the destruction of entities, etc. Next, we want to implement the NPC patrol behavior, because that's a bit easier than the NPC follow behavior. But implement the NPC follow behavior without doing vision calculations first, okay? So if we go to the AI system, this is where you're going to do that. So you're going to implement the follow behavior of all entities and the patrol behavior of all entities. So here you'll just loop over all your entities and say, oh, do they have a patrol component? If so, do this. Do they have a follow component? If so, do this. So over here in the components, you can see now we have a damage component, we have an invincibility component, a health component, in our bounding box component, we now have block move and block vision. You're reading that in from the config file. And we have state, again, like in assignment 3. And we have follow player behavior and a patrol behavior. So inside the patrol behavior, we actually store a vector of positions. Okay, so let me go over to the blackboard here for a sec. So for the patrol behavior, we are going to have a vector of positions. So we'll have like positions. Ooh, that's gross. So positions equals, and we've got our like position here. Maybe we got like 1, 0, and then 5, 0, and then like 0, 5. Okay, so if these are our 3 patrol positions, so if we are, let's make a little sample level here. I gotta make that a little bit bigger. Okay, so if my patrol positions are 1, 0, then that would be like right here. And then 5, 0, 1, 2, 3, 4, 5. And then 0, 5, 0, 1, 2, 3, 4, 5. So these are my 3 patrol positions here. Let me go back and change that. So that is not zeros. So positions equal, let's go 1, 1. And then I've got maybe 5, 1. Then I have 5, 4. And then maybe I have 2, 4. Okay, yeah, so let's do this one. So here's how you're going to implement that. This is the patrol position. So let's say you've got your level here. I know that this is a bit smaller, but I just want to make sure that I'm doing it right. And it's a bit easier to draw. So I've got position 1, 1 right here. I've got position 1, 2, 3, 4, 5, 1. I've got position 5, 1, 2, 3, 4. And I've got position 0, 1, 2, 1, 2, 3, 4. So what happens is the enemy is going to spawn somewhere in the level. Let's say its spawn position is like right here. What it's going to do is it's going to first have this current position index. This current position is the index into the positions vector of the current place that it wants to go. Okay, so what that means is that my current position, I'm going to say current equals 0. So that means that it's going to start off as 0, and wherever my NPC is, it's going to want to walk at its given speed toward... Okay, how am I going to do this? I guess I'll show it with a... All right, so it's going to want to walk toward index 0 of your patrol array. So that is 1, 1. When it gets to within 5 pixels of that position, then you're going to update this index to be index 1. So now you're heading toward 5, 1. So now we head toward this one, and when we get within 5 pixels of that, we increment this to 2, and then we walk down here, and then we increment it to 3. Now we walk toward this one, we get to that one, we go to 4. Oh, there is no index 4, right? So the index is going to be +1 mod the length. So we go back to index 0. And so now we're walking to this one. So what you'll see is wherever we start, we go to the first patrol position. It might even start at the first patrol position. Then when we get close enough to that, we go to the next one, the next one, the next one. And if it's the last one, we loop back around to the start. Okay, so that's how we implement the patrolling position, the patrolling behavior. That's not that bad. I think you're all capable of doing that one. Okay, so then you implement the follow behavior without vision. After you've gotten the follow behavior done, you're going to implement the physics line intersect function, which will allow you to test whether or not 2 line segments A, B, and CD they intersect, and where they intersect. So over in physics, there is this line intersect. Okay, so this is the function that we went over in class in the line intersection lecture. We did all of that math for you, and I basically wrote this function for you. So you can just go take that and copy and paste it and edit it to be valid C++. After you've done line intersect, you are going to implement physics entity intersect, which will allow you to test whether line segment AB intersects with any lines of the bounding box of entity E. All right, so how do we do that? Well, here's how we do that. I'm going to come back in here. I'm going to delete all this stuff. Okay, so what we're going to have in our game is we're going to have an entity. Say this entity is over here. And we're going to have the player, and I'll put the player in purple over here. Ah, that's not purple. This is what I wanted. And then like this. So the player is in purple, the entity is over here. Actually, let me do this in yellow for the... Oh my god, I'm so bad. So the entity is in yellow, and the... No, I want these to be black. Perfect. Okay. Entity in yellow, and the player is going to be, let's say, purple over here. Okay, so what we're going to want to do is see whether or not there is a line of sight between the center of the players, right? This is our, oh no, exposed myself in my Blackboard technologies. Okay, so this is what we're going to have to want to calculate. And if there's anything in the game that blocks this vision, we're going to want to know that, okay? So for example, if this thing is, I'm so bad. If this entity is right here, then the vision is blocked, right? Of course, if it blocks vision. So let's look at that calculation and how we're going to do that. So we already know the math behind, okay, if I have this line segment intersection, if I have this line segment and this line segment, I know how to calculate that. So if this is point A, this is point B, this is C, and this is D, I know how to calculate if there's a line segment and whether or not that exists, right? Or whether or not an intersection exists. and where that intersection is. So what we're going to want to do for this assignment is the following. I may have a big ol' blocker right in the middle. So let's say that this is an entity and this right here represent its bounding box, these black lines. So if this entity blocks vision, I'm going to want to know if it blocks vision. If it does, then the NPC cannot see my character, and so it won't move. However, how am I going to do that? Well, the way I'm going to do it is by calculating the 4 line segments that make up the entity's bounding box and doing the line segment intersection check with any of them. So an entity blocks vision if the line between the player and the entity is intersecting with any of the lines of the bounding box of that entity. So how do you do that? Well, each entity is going to have a center position. It's going to have a bounding box, right? And so you can figure out this. So we have this distance in our code. We have this distance in our code. So you're going to figure out A, you're going to figure out B, you're going to figure out C, and then you're going to figure out D, right? So you're going to figure out the XY of A, the XY of B, the XY of C, and the XY of D. And then you have to do 4 intersection points. So if this point is player and this point is enemy, then you want to know the following intersects. Does line segment PE intersect with AB, right? Does PE intersect with BC? Does PE intersect with CD? And does PE intersect with AD? So if PE, meaning this line right here, if that intersects with any of these 4 lines, then the vision is blocked. All right? So if I go back to my code here, or sorry, if I go back to right here, I have a function called entity intersect. So entity intersect, you're going to be given, this is in the actual code, this is A, okay? This is A, and this is B. This is like, let's just call this E1, E2, E3, and E4, right? This is the entities things. So now I want to say, okay, does AB intersect with E1, E2? Does AB intersect with E2, E3? Does AB intersect with E3, E4? And does AB intersect with E4, E1? So what you do over here in entity intersect is you figure out those 4 points. So you'll say vec2 E1 equals, and you'll figure out the math for that. Then you'll say vec2 E2, you'll figure out that one. So you'll have E1, E2, E3, and E4. Those are the 4 corners of your entity. And then you'll do line intersect A, B, E1, E2. Right? You'll do that one. You'll do E2, E3, E3, E4, and E4, E1. And if any of those are true, right? If any of those are true, if they do intersect, then you return true. And so this essentially says, does the line segment AB intersect with the bounding box of this entity? Then in your system where you implement the follow behavior, you're going to use, for each entity, you're going to say, okay, figure out the line segment AB between the player and the entity. And then for each entity that blocks vision, you're going to call entity intersect on that. So that should be pretty easy to do. Let me delete all this stuff that I just did. Okay. So that is entity intersect and the math behind that. Next, so that's implement NPC follow behavior. using this to check the line of sight. So I already just said that. Next, implement invincibility frames. So invincibility frames are done over here. I have a status. So in my status system now, that's where I implement lifespan and invincibility frames. So in invincibility frames, if I go over to my component, I have this invincibility. So I have a current amount of iframes. So whenever the player is not invincible and it gets hit, I'm going to attach an invincibility component and give it some duration. Okay? And then that duration is going to be handled here. And you're going to see, oops. Where did that go? Status. The invincibility, you're going to handle that there. So you're going to say for each NPC, if it currently has an or if for the player, I guess, because the NPCs don't have iframes, if he has a invincibility component, then subtract from the duration. If the duration is up, then remove the invincibility component. Implement Hearth Pickups. So that's in your collision system. So collision. Here you go. So entity Hearth Pickups, then implement black tile teleporting. So that is right here. Maybe I'll put that to the bottom. So black tile teleporting just says if I have collided with a tile that has the black animation, then I teleport to another random location that has that same black animation. Okay. And that's it. That's the assignment. So all of your code will be in scenezelda.cpp and in physics.cpp. All the rest of the code has been done for you. That's assignment 4. Let's look over the marks real quick. Here we go. Marks. Okay. So code style, modularity, readability. Let's see here. Yeah, okay. So drawing and animations, that's going to be worth 20. So all entities... actually, you know what? I'm not going to read all of this. Here are all your marks. You know what you're going to lose if you don't do something. So it's pretty well spelled out, all the different functionality. Okay. Did I say anything here about custom level? All right. Last thing I want to do is I want you to create your own level. Forgot to put that in here. 1 second. Custom. Oops, sorry, this is still running. All right. So custom level. Include your own custom level as level2.text, which contains at least 2 rooms worth of interesting gameplay. All right, so there's a custom level down here, which is worth 5%, and I just forgot to mention it here. You are going to make your own custom level file and put something interesting in that, okay? Just like assignment 3, I want you to make a little level. That's it. That is assignment 4. So here we have assignment 4. The rest of the stuff that we're going to be learning for the rest of the term is all related to the project, okay? So there you go. It's all project stuff. So we're going to be talking about cool stuff like user interfaces, how to profile your code to make it faster, caching and memory pooling, advanced game loops, shaders, particle systems, all sorts of stuff that I find really cool about game programming. All right, thanks so much for tuning in. Good luck with assignment 4. It will be released by midnight tonight, and see you in the next lecture.